Hey there, science fans! Welcome back to another exciting journey into the world of technology. Today we're diving deep into the fascinating realm of computer networks. Have you ever wondered how your messages, videos and emails travel across the internet to reach their destinations? Imagine a bustling highway, teeming with cars zipping around at high speeds. Each car has a specific destination, just like the data packets on the internet. These data packets are like the vehicles on this highway, each carrying important information from one point to another. But how do they know where to go and how to get there efficiently? Just like our roads need traffic signs and rules to prevent chaos, the internet requires a set of protocols to manage the flow of data. Without these rules, data packets would collide, get lost, or take forever to reach their destinations. Enter the TCP IP protocol suite, the unsung hero of the internet. This suite is a collection of protocols that dictate how data should be packaged, addressed, transmitted, routed, and received. Think of it as the rulebook for the internet highway, ensuring that data travels smoothly and efficiently from one point to another. The TCP IP suite is divided into several layers, each with its own specific responsibilities. These layers work together to handle different aspects of data communication. One of the most crucial layers is the transport layer. Imagine it as the traffic controllers on our highway, managing the flow of vehicles to prevent congestion and ensure smooth travel. The transport layer's job is to ensure that data packets reach their destinations reliably and efficiently without getting lost or arriving out of order. Within this layer, two of the most important protocols are TCP and UDP. These protocols are like different types of delivery services, each with its own unique approach to transporting data. TCP, or Transmission Control Protocol, is like a reliable delivery truck. It ensures that every single packet of data arrives at its destination in the correct order, making it perfect for tasks that require accuracy, like sending emails or loading web pages. TCP achieves this reliability through a process called the handshake, where it establishes a connection between the sender and receiver before any data is sent. This ensures that both parties are ready to communicate and that the data will be delivered correctly. On the other hand, UDP, or User Datagram Protocol, is like a speedy bike courier. It doesn't worry about ensuring every packet arrives or is in order. Instead, it focuses on speed, making it ideal for real-time applications like video streaming or online gaming. While TCP is all about reliability and accuracy, UDP is about speed and efficiency. Depending on the situation, one protocol may be more suitable than the other. So the next time you send a message, stream a video, or play an online game, remember the incredible journey your data takes. Thanks to the TCP IP protocol suite and its traffic controllers, our digital world runs smoothly and efficiently. Stay curious and keep exploring the amazing world of technology. Until next time, science fans. First up, we have TCP, short for Transmission Control Protocol. Think of TCP as the reliable postal service of the internet. When you absolutely, positively need to get your data delivered without any errors, TCP is your go-to guy. Here's how it works. TCP establishes a connection between two devices before transmitting data. It's like calling ahead to make sure someone's home to receive the package. Then it breaks down the data into smaller packets and numbers them. Now let's meet UDP, or User Datagram Protocol. If TCP is the postal service, UDP is like sending a postcard. It's faster and more lightweight, but doesn't offer the same guarantees as TCP. UDP doesn't bother with establishing a connection beforehand. It's like tossing a postcard in the mailbox without worrying if anyone's home to receive it. UDP packets are like those postcards, smaller and quicker, but with no guarantee of delivery or order. So far, we've seen how TCP and UDP deliver data packets. But how do these packets know which application to talk to? That's where port numbers come in. Imagine a large apartment building. Each apartment has a unique number, right? Similarly, each application or service on a computer uses specific port numbers. These ports act like addresses, ensuring data packets reach the correct destination. Section 5. TCP's guarantees like a signed, sealed and delivered package. Remember how TCP is the reliable one? Well, it offers several guarantees to ensure data arrives safely and in order. Firstly, TCP establishes a connection like a handshake before transmitting data. This ensures both devices are ready. Secondly, it uses sequence numbers to keep track of each packet. This way, even if packets arrive out of order, the receiver can reassemble them correctly. Section 6 UDP's speed when you want it fast, not perfect. On the other hand, UDP doesn't bother with these formalities. It's all about speed and efficiency. UDP doesn't establish a connection or guarantee delivery. It's like throwing a ball and hoping it reaches the other person. While this might seem risky, UDP is perfect for applications where speed is more crucial than absolute reliability. Think of video streaming or online gaming, where a few dropped packets won't ruin the experience. Section 7, port numbers in action from web browsing to video calls. Now, let's see those port numbers in action. Port numbers are essential for directing traffic on the internet, ensuring that data packets reach their correct destinations. They act like doors in a large building, guiding information to the right room. Every time you browse the web, your browser uses port 80 for HTTP traffic. This port is the standard for transferring web pages and other resources from a server to your browser. It's like the main entrance to a building where most of the general traffic goes through. For secure web browsing, port 443 is used for HTTPS. This port ensures that the data transferred between your browser and the server is encrypted, protecting it from eavesdroppers. Think of it as a secure vault door, ensuring that only authorized personnel can access the contents inside. When you watch a YouTube video, it might use port 1935 for streaming. This port is optimized for the high-speed transfer of video data, allowing you to enjoy smooth playback without interruptions. It's like a dedicated express lane for video content. Even your video calls rely on specific ports. These ports ensure that the audio and video data are transmitted efficiently, providing a clear and stable connection. Without these dedicated ports, your video calls would be prone to lag and poor quality. For instance, Skype uses a range of ports, including 50,000 to 59,999. For its communication. This wide range allows Skype to maintain a reliable connection even if some ports are blocked or congested. It's like having multiple backup routes to ensure that your call gets through no matter what. Firewalls also play a crucial role in managing port numbers. They monitor and control incoming and outgoing network traffic based on predetermined security rules. By configuring which ports are open or closed, firewalls help protect your network from unauthorized access and potential threats. Network administrators often configure port settings to optimize performance and security. By understanding which ports are used by different applications, they can ensure that the network runs smoothly and securely. This meticulous management is essential for maintaining the integrity and efficiency of any network. In today's interconnected world, port numbers are more important than ever. They enable seamless communication between a multitude of devices and services, from web browsing and video streaming to online gaming and remote work. Understanding how port numbers work can give you a deeper appreciation of the complex systems that power our digital lives. So, the next time you browse the web, watch a video, or make a video call, remember the vital role that port numbers play in making it all possible. They are the unsung heroes of the internet, quietly ensuring that our digital experiences are smooth, secure, and efficient. Section 8, choosing the right protocol, when to use TCP versus UDP. So when should you use TCP versus UDP? It all depends on the application's requirements. Need guaranteed delivery and error checking? TCP is your best bet. Need speed and efficiency, even if it means sacrificing some reliability? Go with UDP. For instance, email and file transfer rely on TCP, while online gaming and video conferencing often use UDP. It's all about choosing the right tool for the job. Section 9, wrapping up TCP and UDP, different but equally important. That's TCP and UDP in a nutshell. These two protocols are the backbone of how data is transmitted over the internet. They each have unique characteristics that make them suitable for different types of data transmission. Two different protocols, both crucial for the internet as we know it. TCP, or Transmission Control Protocol, is known for its reliability. It ensures that data packets are delivered in the correct order and without errors. This makes it ideal for applications where data integrity is paramount, such as web browsing, email, and file transfers. TCP is like the reliable postal service, ensuring your data reaches its destination safely. Just as a postal service tracks and confirms the delivery of packages, TCP tracks data packets and ensures they are received correctly. If any packets are lost or corrupted, TCP will retransmit them until they are correctly received. UDP, or User Datagram Protocol, is like the speedy messenger, prioritizing speed over absolute guarantees. Unlike TCP, UDP does not establish a connection before sending data and does not check for errors or ensure that packets are received in order. This makes UDP faster and more efficient for applications where speed is more important than reliability, such as live streaming, online gaming, and voice-over IP, VoIP. Understanding these protocols helps us appreciate the complexities of computer networks and how data travels seamlessly across the globe. Each protocol has its strengths and weaknesses, and they are often used together to provide a balance of speed and reliability. For example, a video streaming service might use TCP to ensure the initial connection and metadata are transmitted reliably, while using UDP to stream the video data quickly and efficiently. So next time you're browsing the web or streaming your favorite show, remember the invisible heroes, TCP and UDP, working behind the scenes. These protocols are the unsung champions of the internet, ensuring that data is transmitted quickly and reliably. Stay curious, science fans. The more we understand about these technologies, the more we can appreciate the incredible complexity and ingenuity that goes into making the internet work.